Hi guys, my name is Karahan. I'm the Business Development Manager from Calbase Systems. Today I'm going to talk about a project that we've been working on for about 3 years now from the requirement spec to design, full implementation, and deployment. This is a system that we've been designing for the Lawrence Berkeley National Lab's FLEXLAB facility. So what is FLEXLAB? FLEXLAB is a heavily instrumented facility made up of a collection of test beds for studying and demonstrating energy-efficient building systems. It's a facility that is designed for engineers and for the industry to test their new technologies. So it's a catch-all type of facility. It's a collection of test beds, exterior test beds, and light and plug load test beds, and also a facility that gives the users virtual design and visualization capability and control hardware. So this is a model of the facility. It is actually being realized now. So if you go into LBNL, you can see some of this. But it's kind of cool. There's a rotating building that rotates 270 degrees and a collection of stationary test beds that is heavily instrumented. So FLEXLAB folks came to Calbase, like I said, about 3 years ago. And we started with basically collecting the requirements for the facility just so we can come up with a design. It was a very, very difficult effort. There was a very large number of stakeholders. But the high-level needs for the facility is basically to give low-level control of HVAC, lighting, shading, and other sequences and control scripts to the ultimate end users of the facility, which are researchers and scientists. We wanted to give the facility interoperability and give the ability to accept a wide range of different I/O types, and also provide an external tool interface. In this industry, there's existing technology that we wanted to be able to adapt to, and also allow the users to use MATLAB and Simulink and things like that. So I included this slide just to kind of communicate the overall idea. So basically, what we're trying to do is put our instrumentation and control system on one side of the wall and give basically a patch panel with all kinds of connectors where external sensors, external things can be plugged into the system and be able to play with the existing software. So that's what the whole software is designed after, is to be able to support what we don't necessarily know. So we group things by channel types, and basically, somebody can bring in a particular sensor 3 years from now, plug it in, and be able to integrate that into their overall experiment. We're also giving, in our software, the ability to come up with the sequences. So basically, we're building the building blocks for the researchers to ultimately use this system. At a very high level, we'd break it down to these 5 major groups. There's a central server that talks to basically the entire facility. There's individual cell workstations with different applications running on them. These are all custom things. Support for external simulation tools. There's a database that's central to the entire facility. And also the hardware, the transducers and the sensors that are going to be plugged in. High-level hardware requirements, like I mentioned already, a wide range of input and output. What we ended up using is the National Instruments CREO platform. Basically, each test cell is equipped with its own chassis that supports a certain number of I/O types, channel count. We also wanted to give, we were also required to provide support for Modbus and BACnet, and be able to give them a system that was very easily reconfigurable in the future. So, by definition, this is a research facility, and we don't necessarily know exactly what the research will entail in the long term. But we want to give them the framework that will support what that research need might be in the long term. The hardware solution highlights, again, it's a CREO system. There's tight deterministic control, easily expandable via Cat5. Each CREO target is deployed with its own application. And ultimately, internally, the FLEXLAB staff needs to be able to change these applications, what is deployed to these targets. but out of the box they come ready to go. I'm going to go to a potential use case here. Again, basic idea, you have your serial chassis. Here you see a weather channel, for instance. So the type of I/O we're supporting, like I said, is very vast, but there's also wireless support. So you plug it in, and it will automatically appear in your configuration where the researcher will take whatever sensor reading it is, work it into an overall sequence, and build a new sequence that represents his experiment. So this is on the software side. There's a lot going on in this slide. But again, we have our own dedicated API that was built particularly for this application. We can actually refer to each channel over TCP/IP, which was kind of required to give that long-term support and have them help themselves, basically. You see the local storage and also the interstate server, which is actually a company. We didn't invent that. It's a tool. It's a test data management tool that we designed into this facility. It is customized for this application, but the basic level of support was already in as a product. There's a lot of GUIs here. A lot of configuration GUIs, and there's a component called the CalBay adapter, which is kind of the heart of the system. We named it CalBay adapter because we couldn't find a better name for it, but it is basically where you configure all the channels and everything in one place. I just put one of the GUIs in here. This kind of gives you a feel of how everything kind of plugs in. Like I said, there's a lot of GUIs, but in this simple GUI, the channel names from a variety of different test cells show up in one place. You can pick and choose what you're going to graph. It's pretty self-explanatory data viewer. Everything is web accessible also. On the hardware side, we talked about this already, but there's a variety of serial modules. They're very, very generic in their ability to accept new sensors. Basically, just pick and choose different sensor types. Chances are there's support for it, but more importantly, there's a bunch of open slots in the serial chassis where we can add additional channels in the future. So that was the cell level. This is a bed level. So each bed consists of 2 cells. So we have instrumentation for each cell, but also that's common to the bed. Same idea. Open channels and also a variety of different input modules. So I mentioned that we've been working on this for over 3 years now. Not 3 years of development, but 3 years of requirements, gathering, activity, and design. And there's a variety of lessons learned from this activity. In this case, there's a huge number of stakeholders that we need to satisfy. And just to gather the requirements from all these different stakeholders, identify the gaps and overlaps, is a huge challenge. And I would list that as the #1 lesson learned. Controlling the requirements phase, just defining this is when it starts and this is when it ends, and now we're going into design, we can't get more requirements. Just to be able to control that has been a challenge too. Change orders and traceability with the large number of stakeholders and changing requirements, just to keep constant the project artifacts so that the project manager can control project scope and deliver what we promised. Has not been easy, but we're getting to the end of it here, and I think we've figured out some things. On the design and implementation side, requirements are one thing, but in this case, we had to really concentrate on different use cases that are important to the different scientists that are giving the requirements input. On the validation deployment, which right now we're at a phase where we're going through a lot of validation and deployment phase of the project. It's a large construction project. There's a lot of different types of vendors. We're not necessarily used to working with construction type vendors. I mean, there's buildings that are rotating 270 degrees. There's a lot going on, a lot of different stakeholders. But to work in that large environment, it has definitely been fun and challenging at the same time. And validating on the bench it is something that we had to do a lot because ultimately what we're deploying to wasn't necessarily ready yet. It's a building that's not ready yet. But a lot of that is slowly coming to an end, and we're all very excited to see how this turns out. I'm very hopeful, and everything is looking like it's a go.